Let's start. So, a quick recap for last lecture. When we went through the introduction and we covered first 5 videos, which actually which are associated with first 5 topics that we will cover for the entire course. Today we will continue and finish the remaining part for the introduction. So basically, for the first half of this lecture, we will finish covering all the topics we're going to talk about and give you a basic idea of all the subjects. And then for the second half, if we have enough time left, we will start talking about learning a new programming language. And then I will so for our course, since we don't have enough time, I will actually leave it up to you guys about how to actually learn the Ruby language, but still we can cover some principles in terms of learning a new language and some useful tools that I think worth recommending. And those tools usually applies to all the programming languages. So those are usually the things that can be helpful for someone new to a language to quickly pick it up and master the language to some extent. Alright, so without further ado, let's continue with the videos. We haven't finished yet for module 1.
Productivity. So why do we care about productivity? To be frank, hardware has gotten so fast and so inexpensive over 5 or 6 decades that we're writing more and more sophisticated software to be able to take advantage of that hardware, right? All of those hundreds of thousands of servers. So in order to write software at that level of complexity, we need to be able to write it more productively. Right? People used to write stuff in basically bare machine language and assembly language. You wouldn't think of writing something like a web-facing app in assembly language. Or if you do, you're some sort of masochist. So what have we done instead to make the job of software writers more productive so that we can get more functionality in software with less grungy work? So there's a couple of different productivity mechanisms that we're going to use. Essentially, the 4 that we focus on in this course, one of them is, believe it or not, code that writes other code. There's cases where the code that needs to be generated is based on some sort of a template, and we can actually do some code generation in advance, save ourselves a little work. We can also strive to make our code clearer by making it more concise. Anytime that we can say less and do more, we've reduced the cognitive load on the person who's going to read our code. If they can look at a few lines of code and get the basic idea of what's supposed to be going on, because we're using concise notation, remember when who are you writing code for? You're writing it for like the you of 6 months from now when you come back to your code and try to remember what were you thinking when you wrote it. So one way to do that is try to achieve as much clarity as possible, and one way to achieve clarity is make the notation concise and clean. I'll give an example. Reuse. We all know that reuse is like the holy grail of software, right? Don't do work that someone has already done. Now, in some sense, that is easier said than done, and one of the challenges when we start talking about refactoring is you identify that there are places in your app where you essentially have nearly duplicate code because you're trying to do almost the same thing. And the trick is, can you extract the common part, reuse it, and now you've eliminated the cognitive load of understanding code in 2 different places. So what are the different mechanisms of reuse that we're going to see? And finally, automation and tools. Automation is so your friend. Roughly everything we're going to do in terms of code maintenance, maintaining our databases, deploying the app, running our tests, every one of those is going to be like a one-line thing. Because if you do something manually, it means you could screw it up by doing differently 2 different times by accident. But if you have a script that does the thing, the script is guaranteed to always try to do it the same way every time. And determinism is so your friend. So let's talk about the first couple of these. Code that writes code. The first example of this that we were able to find is something called BitBlit. It's a way of passing a mask over an image, and on each pixel, you do some operation that is a function of the surrounding pixels. And in early implementations, it turned out that the way you would code this is you would have like nested for loops to go across a grid and down the columns. And the interior of the loop was switch one, depending on one of the 8 possible values of this thing, you're either doing an XOR or an AND, or you're replacing one value with another. So it's like you've got nested loops, and in the interior of the nested loops, you've got a conditional. But somebody had the bright idea of like, well, OK, let's say that the thing we want to do in the interior of the loops is an XOR. What we're going to do is at runtime, we will generate a version of the code that hardwires the XOR operation, and will run just that little version of the code. So you essentially generate code at runtime that does the special case. You run the code, which now has no conditional in the middle, and it runs way faster. So there are variations of this that we're going to see. They're all over the place in Ruby, places that generate code to fit the situation and then throw it away. There's also things like templated code generators. We're going to see some examples in Rails where there are certain types of operations, like modifying your database, where there's some amount of boilerplate code that you have to start from. And even though it's not much boilerplate code, it's really nice that you don't actually have to type any of it, because there's a generator that says, give me the template for modifying the database, but then instantiate the template with these specific sets of things to do, which I'm going to fill in. Okay, so that's a code generator. If anybody's ever used flash fill in Excel, this is the thing where you've got like the first name in a column, the last name in a column, and then you're manually creating a column where you're putting first and last name together. And once you've done 2 or 3 examples, Excel like magically figures out what you're doing, and it offers to do the rest of them for you. Does anybody use this feature? This is an example of program synthesis, where you're basically trying to infer a small program that appears to be consistent with everything the user does. So we're not going to talk about it too much in this class, but it's another example of how do you avoid manually writing code if there's any other choice, right? So you could have the code generated from templates, or you could have an algorithm that tries to infer a short program that actually does that specific task. So those are a few examples of generators in code synthesis. And if you're following along in the textbook, anytime you see that icon, it's here is an example of where code generation is hopefully saving you a little bit of effort. What about clarity via conciseness? We already know that higher level languages give you more expressive ways to essentially do more functionality in fewer lines of code compared to things like assembly language. We've long ago left behind manual memory management. The percentage of bugs and security holes that are due to poor memory management is now such that you really need to defend your choice of using a language like C. When we talk about Ruby's mechanisms for reflection and metaprogramming, including, if we have time today, we'll get to talk about one of them, as another way of using a higher level of abstraction to express a task. But even in something as simple as syntax, sometimes you can make simple syntactic choices that reduce your cognitive load by just a little bit. So for example, one of the Ruby testing tools we're going to use, instead of writing something like assert greater than or equal to a comma 7, you can actually write expect a to be greater than or equal to 7. Now, you might look at this and say, OK, that's not rocket science. You're just sort of inventing a slightly nicer, slightly more readable syntax. But if you're reading a lot of test code, the amount of effort that it saves you each time really adds up fast. Being able to just look at the code and seeing, OK, it's pretty clear what this line of the test is trying to check. Every little bit helps. So I think the Ruby community in particular is very, very, they place a lot of value on beautiful code that makes its intent as clear as possible. I know most of you have not done Ruby before, but you're also going to see constructs like this, where if you have an equation where you want to find out, for example, what time was it, what does this mean? The current time, OK, I get that part, but what's going on here? Oh, OK, so 60 minutes are in an hour, 60 seconds are in a minute. So this must be like a way of calculating 2 hours. So this expression must have something to do with calculating what time it was 2 hours ago. Or in Ruby, you can actually just write that. Okay, and we'll see why that works. And again, some people look at that and say, oh yeah, that's really cute. It's like a neat trick. But it's more than a neat trick. It's a way of saying, like, when you look at this, it's pretty darn clear what the programmer's intent is, right? And that is the goal, giving you a way to write something that makes your intent as clear as possible. What about the conciseness part? Here is some code that I actually found on a real website. I don't know if people remember the fiasco when the Obamacare website first went up. It had this horrible, horrible experience. Like the website didn't work, and it went down, and it had poor availability. So in this class, we had a special session investigating what made it so bad. And here's some actual JavaScript code that we found. This is code that, like, if somebody who was taking their first programming class wrote it, I'd be like, OK, I get it. But this is code that appeared in a website that millions of people are supposed to use. Why, in God's name, wouldn't you write something like this? Even if you don't know Ruby, you should be able to read that. Right? In fact, even if you don't know that between is actually a function in Ruby, it's pretty clear what it does. Right? So it's like, here's a good test. Can you read the code? If index is between 0 and 4, then A, B, C, D, E, substring whatever the index is. Otherwise, nothing. Right? So again, it's a way of asking, when I read this code 6 months from now, am I going to understand what I had in mind? Now, let me ask a controversial question about this very example. Understanding that most people don't know Ruby, and that's cool. Let me walk you through this example because I want to ask you a question about it. And here it is. Okay? At the top in red is the exact same thing I just showed. Underneath it is a different version of the expression. In the bottom version, you see that there's no checking about the value of index. Index could have any numeric value. Let's say we can assume it's an integer, but we have no idea if it's between 0 and 4. It might not even be positive. Now, I'm going to tell you, as a matter of definition, that in Ruby, if you make reference to an array subscript for which there is no defined value, Ruby will silently return nil. So it's not an error in Ruby to dereference an array index that has never been initialized. So in some sense, it doesn't matter what the value of index is. If index is 1,000,000, then ABCDE subindex will be nil. I will also tell you that the function to_s is toString. So it will return a string representation of whatever you're calling it on, which means if ABCDE subindex is nil, because index is some crazy value, the string representation of nil happens to be the empty string. So I'm telling you that functionally, the bottom one and the top one will have the same effect. They will both do the right thing, whatever the numeric value of index is. Here's my question. But did people understand that before I ask the question? Are we clear on what the stakes are? Great. That was the setup. That was the exposition. Now we go to the conflict. If we're going for clarity via conciseness, which version, if you're writing this code, which version would you use? Or, is either version sort of, equally good and it's kind of more of a matter of taste? And we're going to do the same thing as before. We're going to vote first, and then we're going to turn to a different person than the person you talked to before, discuss your answer, and then we're going to vote again. Isn't that fun? Take some time to think. Think on your own, but this is not talking time. This is thinking time. This is the time when you think internally. That means we are talking to ourselves, or maybe not at all. I'm pretty sure the answer is yes. Do strings behave the same as arrays, that if you reference a non-existent subscript, you just get back the empty string? I'm sorry? I won't swear to the answer, but I will tell you that the answer to that question should not necessarily influence your answer to this question. OK, so let's see what the voting says so far. Here's the votes. So far, the voting is slightly more people think that the first version is preferable, but it's not like a definitive. Yeah, I should do the thing where I stop the votes, right? OK, so now turn to someone who is different from whoever you talked to before. Talk to them about your answer for like 30 seconds, and then we'll see if that changes any of the results or not. And then we'll discuss it as a group. Whoops, sorry. People left, get them in. Let's 3, 2, 1. All right,
So I
let's see what
just
happens.
skip a bit.
If we
'Cause
re-show,
that 1 minute is
Oh.
basically waiting for a discussion.
very little change. All right, we're gonna. Who is willing to argue for one or the other? Anybody want to champion one or the other position? Go ahead. Which one do you want to champion?
For A,
So the top one.
yeah, the top one's more human readable, and if you, for example, forget the intricacies that the string representation of nil is like an empty string, then you might not know exactly what this means.
So because I'm on the mic, and sorry, what's your name?
Rebecca?
And I'm on the mic and Rebecca is not, so I will repeat, and I hope I paraphrase what you said. The argument is that the top version is probably better because in the bottom version, you have to know that, for example, you'll get nil if you dereference a non-existent array, and you have to know that if you then take nil and try to convert it into a string, you'll get the empty string. So even though in some of these questions there's, quote, no right answer, I am going to come down on the side of that argument. I happen to know Ruby, and I have been doing Ruby for a long time. So if I looked at the bottom one, I'd be like, oh, but what if index is, oh, right, it's OK. And then 2s, oh, right, you need 2s because of it. So I've already done the work, right? I'm never going to get those 8 seconds back. And if you're new to Ruby and you're looking at that bottom one, you should wonder, like, OK, what if index is out of bounds? Is out of bounds even a thing in Ruby? And what value is it returning that it specifically needs to be converted to a string, given that the thing I'm starting from is already a string? So the bottom one is clever. It saves a few characters, but it is higher cognitive load on the developer, and that's the reason that I would come down on the side of the top one. Shorter is not always better. If it's shorter to the point where you have to sort of do unnecessary work just to understand what's going on, maybe you have gone a bit too far. We could hear another perspective.
Yeah, but what if my coworkers don't think I'm clever?
So if your coworkers are looking at the top one and they're saying, hey, why didn't you do the bottom one, which would obviously have been more clever, here's what I would say to those coworkers, and you are free to use this at any time. Brian Kernighan, anybody? Brian Kernighan? Anybody heard of Brian Kernighan? He's the co-inventor of C, a language you may know. He is also one of the core Unix developers. It's suffice to say, Brian Kernighan, when he talks about code, I listen. Brian Kernighan says, debugging is a much more difficult activity than writing code. I don't think anybody here would really fight him on that. Therefore, if you are as clever as possible when writing code, by definition, you have no cleverness remaining to use when it's time to debug your code, which certainly has bugs. So when writing code, err on the side of something that is simple to implement and simple for coworkers to understand. Up to a certain point, it gets better by getting more compact. But if it gets so compact that you find yourself doing extra work, maybe not so much. You may ask, what does this have to do with software engineering? The world, because you're writing code for the you of 6 months from now, right? And like I said, even as a Ruby developer who's been in this language for a while, I have to sort of take an aside to think about, OK, yeah, I'm convinced that that'll work. And that's not good. Okay? There's no, my taking that time out does not in any way increase the value of the code to me. So matter of taste, but there you go. OK? All right. Awesome. So the other two productivity mechanisms we can talk about are reuse, so how to avoid doing work that someone else maybe has already done, and what's the role of tools. So reuse is pretty straightforward, right? Don't write code unless you're pretty sure there isn't existing code that already does what you need. And as we know, there's a lot of different ways we develop to do this. The simplest one is if you have a function that does something, you call that function from all over the place. That's pretty straightforward. There are libraries, sort of collections of related tasks and functionalities. So reusing a library, for example, for parsing dates and times or doing data arithmetic, saves you from having to do that. We're going to we're going to be using a concept called interfaces or mix-ins, depending on which language you come from, is a way of reusing behaviors across different classes in object-oriented programming. So a class is a useful abstraction because it sort of collects a group of methods together that do related operations on some well-defined set of data. That's kind of what a class is. But sometimes there are behaviors that you would like to reuse even when the classes are different. What would an example of that be? Well, think about the behavior of sorting a collection of items, right? You could make the strong case that a sorting algorithm, right, whether you choose quicksort or binary something or bubble sort, heaven help us, but the logical act of sorting doesn't really depend on the thing being sorted. Whether you're sorting numbers or strings or bank account records, as long as you have a way to compare any two elements of the collection and have them satisfy the triangle inequality, ideally, then the act of sorting doesn't really depend on what the collection types are. And in fact, it shouldn't even depend on what type of a collection it is. For example, if I'm sorting a linear array versus sorting the list of lines in a file versus sorting a list of records coming out of a database, again, the underlying type of the collection is not important. What's important is that the collection has a way to say, I can give you an element at any time, or I can always give you the next element, or I can tell you when you have run out of elements. So behaviors like sorting are actually very general, but the language needs to give you a way to nicely reuse the behaviors, even though the specific classes are different. And in Ruby, that behavior is called a mix-in, and when we start doing some kind of idiomatic Ruby next week, you'll start seeing some of it. And later in the course, we're going to talk about design patterns. Design patterns are extremely general because they're not about reusing lines of code, they're about reusing a strategy. For example, the idea that there's a client and there's a server in the web world, and the client is specialized to do certain kinds of things, the server is specialized to do very different kinds of things, and that leads to some choices about, for example, the communication protocol between the client and the server and how we choose to structure it. Every client-server system may have its own code base, but the code bases will all sort of follow some certain patterns because the idea of having these differently specialized entities is common to all of them. So we're going to see a large collection of things like that under the general heading of design patterns. And like most patterns, they only emerge after somebody's done it almost the same way a bunch of times and said, you know, there's actually something more general here that we should pull out. So almost every kind of reuse is at some point somebody said, you know, we did this 5 times and it's almost the same thing each time. Can we abstract out the parts that are the same so that you can sort of wrap the parts that are different and take advantage of the extra work? One of the mottos that I'll be nailing on this a lot is called DRY, for don't repeat yourself. The first mention of this that we know of was from Hunt and Thomas. They said every piece of knowledge in the system has a single unambiguous place where it's represented, which means, for example, you know, if there's the maximum number of users in the system or the maximum length that somebody's name is allowed to be, there's exactly one place that is easy to find, that is obvious, and it's well documented. And as we'll see, with so many of these other things, it is easier said than done. But if you do it, it means that when you have to repair something or when you have to change something, you avoid the problem of having to change it in multiple places and wondering if you got them all right. So what are we going to do in this course that addresses this opportunity? A lot of refactoring. A good deal of refactoring is exactly this. You realize that there's 2 or 3 places in your app where you're doing almost the same thing, and you're sort of doing it kind of half-assed 3 different ways, and you'd like to use your whole ass and do it once and capture the commonality. Centralizing knowledge of housekeeping tasks. So a lot of housekeeping tasks like updating the database, deploying, making sure all your tests run, writing scripts or using tools that help you automate those things so that there's one place to go to say, wait a minute, if the whatever test fails, where do I go to look at the results and find out what happened? And as we'll see, there's tools like rake in Ruby, the classic make tool that probably everybody has used at some point, build systems like Ant. This is what those tools do, right? They're trying to centralize in one place the knowledge of how to do certain important tasks. Which brings us to tools and automations. Automatic is the way to go. If you do it manually, you probably will not do it exactly the same way every time. That's the reason that tools like Make were invented. They can do things like track dependencies for you and make sure that the steps that need to be done actually get done in the right order. Every tool has a learning curve, and I think one of the most challenging things in software is agreeing that you're going to attack the tool and learn its learning curve, because in the long run, the productivity gain is going to outweigh the effort you took to do that. And I know that there are sometimes when it feels like that day where you cross over seems like it's really far away. But believe me, it is worth sticking to. I would say I learn probably 2 or 3 new tools a year. And it's always because, you know, sort of reading about them and hearing my colleagues talk about them, it's clear that I'm going to get paid back. Right, that I'm going to get paid back because my tests will be more thorough, because I'll get quicker feedback on how my code's doing. So we're going to ask you to learn a lot of tools. And it's a life skill, so I view it as an opportunity. So you're welcome about that. The other nice thing about tools, though, is that unlike a manual procedure, a tool can be instrumented. The tool can keep track of what it's doing. It can record data about what it's doing. So in addition to being able to do the same thing every time, you can track how you're doing. How many bugs did your tool actually find this week compared to last week? Did your test coverage from last week go up, or did it go down, or did it stay the same? How often did somebody take a look at your commit on GitHub before saying, OK, your code looks good, it's ready to merge it? So tools can actually tell you something about how your work is going and how your team's work is going. And in fact, we have some experimental tools we're developing for this class, which you will get to use in your project that we hope will help your team do exactly that. So the summary is this is a lifetime learning thing. You're going to get to use lots of tools in this course. And it's like learning a language, right? Learning how to learn a tool is a good life skill to have. So we hope that that's something you'll come out of.
Okay, so that was a pretty long video. To summarize it, I will say, so I believe in order for a programmer or a developer to be successful, you've got to be lazy. Not in the sense where you just just want to slack and then don't do anything, don't work. Not in the sense of that, but lazy in the sense where you strive to save the time and effort, basically trying even learning new things in order to save your time writing code or save time reading code, right? Whether being writing beautiful code, learning a tool, or apply some of the design patterns, write up your code, the stuff that the professor mentioned in the video. Or in the other world, which was the first slide in that video, basically to achieve better productivity, right? Really, I want to encourage everybody, don't be afraid of learning new things, especially for software development. I mean, technology changes every day, and honestly, every month or every quarter, you will see something new that comes up. And actually, something you use today, some tool you use today, may no longer be relevant 1 or 2 years down the line. And taking this example, like Ruby on Rails, every few years it actually iterates. It implements new modules, new components, new functionality, and at the same time throw away some other functionality. So in a sense, I started using Ruby on Rails from Rails 4, and then a few years ago it has iterated to Rails 5, which is pretty different from Rails 4. And actually 1-2 years ago they released Rails 6, so that's yet another thing to learn. So yeah, that's what I want to say about this video. Basically, it's talking about different principles that could help us to be more productive when doing works or writing program, basically. And I want to encourage everybody, try to be lazy in the sense that be more productive. Don't be afraid of learning new things, as long as the new tool can help you save time. And then in most of the cases, the popular tools, I think most of the popular tools can indeed save your time and be beneficial. Well, you could say like, oh, I may just kidding. Let's say like you got a terminal illness and may just pass away in a few months. Then okay, I agree that probably you don't need to learn a new tool. But I don't think anybody here is going to die, right? Then in long term, it's always beneficial to learn a new tool. And then for me, I think on average, every quarter, I would explore something new. Don't have to master. When we talk about learning a new tool, you don't really need to master it. And actually, it's not possible to just master a tool like without actually using it in real world projects, stuff like that. So when we talk about learning a new tool or learn something new, um, we're just saying, explore it, understand the concept, and then know some basic stuff about the tool, to the extent where you could actually get started with it, for like a experimental project. And of course, you can master it along the way when you actually use it in a real world project. All right, so that's about that video. Let's move on to the next one.
So we sort of know that the way this class is focused is around software as a service. At this point, it's hard to imagine that there ever really was any other kind of software, because no matter what sort of cool, nifty device you have in your pocket or in your house, pretty much the thing that all of them have in common is they're much more interesting because there's a piece of it that runs in the cloud. So there's a cloud part and there's a client part. And as recently as sort of the 1990s, that wasn't really the case. Up until about the mid-1990s, shrink-wrap software was what you had, the thing that you download and actually install on your computer. And of course, we now realize that, compared to shrink-wrap software, if the software is mostly running in the infrastructure, first of all, your data is safely stored somewhere else. So not that I like to lose my computer, but if my computer was run over by a truck today, I would sort of lose a day's worth of inconvenience in getting my hands on another one. But my data would be spoken for, and you can collaborate, right? It's much easier to collaborate on data stored in the cloud. So software as a service immediately had sort of that advantage. And from the point of view of a developer, if you're a developer, you don't have to worry about, which operating system does my customer have, which version of the operating system. There's one version of the operating system, and it's the version that you're deploying your software as a service on. So there's no install hassles for the end user. Basically, if they have a web browser, they're good to go. There's no development hassle for you having to worry about multiple different kinds of computers and operating systems, which means there's a lot fewer compatibility headaches. And you can also do cool things like if you have a new feature and you're not sure if it'll work well, you can randomly choose like 1% of your users to test it on. And based on how those users interact with the feature, you can decide what to do with it. Upgrading is a lot easier, right? Instead of having to, hopefully everyone will download the brand new binary and install it on their phone or on their PC, upgrade just means you deploy the newest version to the cloud. And the next time their browser or their mobile app front end hits it, they will get the updated version of the software. And finally, we know that one of the keys of Agile is continuous customer feedback. Well, if you're deploying new features all the time and you can get them out that quickly, what a great way to get rapid customer feedback. So in some sense, it shouldn't be too surprising that the time the Agile Manifesto sort of started to take off, which was the early 2000s, is also as the time when software as a service was really starting to take off. Right? They're almost made for each other because software as a service makes possible the exact thing that Agile proponents say is one of the big strengths of Agile. Less risk in terms of having time that you've spent building something without customer feedback to know if you're building the right thing.
All right, that's a short one. What I want to bring up is that even though in this course, the example we use software as a service or web application as an example, in your work, possibly like if you work on a mobile application project, then it's actually a different story because the basic premise that we're making here for SaaS or Agile, it's based on we're basically deploy one copy of the software, and then everybody will use it through a web browser. And then that basically eliminates the compatibility issue. Well, actually, there's still some compatibility issue in terms of the front end, but let's ignore it for now. But That's a different story for mobile app. Um, the same app may run on iOS, will definitely not run on Android if you're building native, right? And even if you are building hybrid, it can behave really different. And then the deployment cycle is also different. For a website, again, it's really fast. If you find a bug, you fix it, you release it right away, and then all the web requests after that will get to the good one. So they won't experience the bug, and automatically the bug fix is applied to everyone. But for the mobile app, and especially for Apple, I would say, for iOS app, because App Store, it takes like at least like a day, sometimes 2 or 3 days to review your app. So if you notice a bug, fix it and roll it out. It will take like 2 or 3 days before it hits the customer. And then in some cases, like if you introduce a really bad bug into your release, there's no way actually to immediately fix it. You always need to wait, especially for iPhone. You always need to wait for them to review the new release and then roll it out. And on top of that, according to my experience, for some reason there are users who just never update the app. So in that case, the bug will always be there for those users who never update. Of course, there are ways to force users to upgrade an app. Otherwise, basically you can write a code, tell the app to check the version. If the version doesn't match the current version, you could have a pop-up or something to force the user to upgrade it. But that aside, if you don't do that, there are cases where there will be users who are behind the release schedules. So in that case, you sometimes can expect 1 or 2 weeks before majority of the user hits the latest release. All right, so then in that case, let's say when you're involved in a mobile app project versus a SaaS project, then how would you adopt the principles we learn? That would be something for you to think about, right? So even though we will talk about many things, good practices, again, I think mentioned quite a few times. Other principles we learn in this course may not necessarily apply to your project. So give it some extra thoughts before you actually apply it when you actually use it. Okay, so let's move on to the next video.
So software as a service is awesome. What does software as a service run on? Well, what are the sort of demands on the infrastructure, right? If you're deploying software as a service, what does it have to be able to do? It has to be able to communicate. Users have to be able to get to the service somehow, so you need a network. You need to be able to accommodate widely varying amounts of users, and this is something that actually really just became practical in the mid-2000s. Until that time, sort of instantaneously scaling up was not something that a typical individual developer or small company was able to do, and now they can. And it needs to be up all the time. Once it's in the infrastructure, users expect that they'll be able to interact with it all the time. So, if you had software installed on your PC, you would expect that anytime you open your PC, you'll be able to use it. If you're relying on software that's in the cloud, you can reasonably expect that whenever you need to use that software, the cloud version is up and running. So how do these demands get met? Essentially, in the 1990s, we started to move the internet infrastructure towards commodity clusters, which means instead of big mainframes, which actually until the mid-1990s were quite prevalent even for things like search engines, we're talking about mostly commodity PCs connected together with mostly commodity networking equipment. Now, I say mostly because software as a service and cloud computing has become so much the dominant mode of deploying software that a good amount of specialization has now occurred in how those commodity servers are built. But at the end of the day, from a programmer's point of view, they basically are souped up x86 or ARM PCs with souped up Ethernet. You program them the same way. The programming model is the same as truly commodity PCs like you would buy for personal use. And it was quickly realized that you can put a lot more of those together than the capacity of the very largest conventional mainframe server that you could buy. So if you run out of capacity on a mainframe, you need to forklift in another mainframe. If you run out of capacity in a cluster, you just need to add more nodes to the cluster. A lot cheaper than conventional servers because, being commodity computers, they were already selling tens of millions of units into consumer markets. So all of the parts, the basic technology required to go into it, was already enjoying economies of scale. Whereas the non-commodity sort of mainframes that used to be the mainstays of data centers, far fewer of those are getting sold. So the price per unit of computation or storage was already going to be much cheaper if you could use commodity equipment. And in fact, and sometimes by up to a factor of 20 cheaper. What about dependability? We need these systems to be dependable. Well, a lot of redundancy. Buy more servers than you need with the assumption that once in a while some servers will fail or will temporarily have to reboot, and you just have enough servers to take up the slack. So it sounds really great on paper as a way to get dependability. And as a bonus, because the servers are all the same, they're all configured the same way, you probably have automated ways to update them, you don't need a lot of human beings to manage enormous numbers of servers. If you're careful about keeping them configured the same way, and you can use technology like virtual machines to do that, very, very few human beings, 2 or 3 human beings for tens of thousands of servers is actually not uncommon. And one of the highest costs of anything in computing and programming is the cost of human labor. So it seems like there's all these potentially great advantages. And indeed, those led to what Luis Barroso, who's one of the chief architects of Google, has called warehouse scale computing. Clusters very quickly went from being order of 1,000 computers to order of hundreds of thousands under a single roof. And that's because there was so much customer demand for the software as a service that was being deployed on those clusters. So what happens? At hundreds of thousands of computers per data center, you start getting really serious economies of scale. And in fact, Google and Amazon and others documented that they were seeing cost reductions of 3 to 8x in the sort of cost of computation and storage because they were buying these things in such huge quantities. You can get a volume discount from manufacturers. You don't need a lot of human operator oversight to manage very large numbers of machines. But the downside of all this was that those same companies found that only about 10 to 20% of the capacity of those data centers was utilized in steady state. So why would that be? Why just 10 to 20%? You build out 100,000 servers in your data center. You're Amazon. Christmas is coming. It's going to be a big shopping season. What happens after Christmas? Something happens after Christmas, kids. Anybody? Yes, New Year's does happen after Christmas. That is astute. However, where I was going with this, and I do have a point, the idea that you can have economy of scale by having huge numbers of servers and serve as many users as you want, it sounds great on paper when you have as many users as you want. But realistically, your demand is not going to be the same all the time. And Amazon was sort of the poster child for this, right? During the holiday season, their demand was order of magnitude more than it was the rest of the year. So it's like the parking lot in the mall, right? The parking lot in the mall has to be large enough for Christmas Eve. But the rest of the year, most of that parking lot is empty. So if you've got a data center and you're only using 10 to 20% of the capacity during your non-peak times, it might occur to you that you could sell off the capacity that you're not using. And to oversimplify only a little, that's kind of where Amazon Web Services came from. All of the facilities that Amazon Web Services has now, anybody use AWS, by the way? Has anybody tried it out? Okay, a number of people. All of that functionality that AWS rolled out in 2007 really was infrastructure that they had built internally to be able to meter and partition their own data centers so that they could manage it better. And the idea that you can now sell this by the hour to end users for a cost less than what most end users would have to pay if they bought equipment themselves, what an interesting idea. And that really only happened in 2007 when Amazon first launched EC2, the Elastic Compute Cloud. And the idea was very appealing. You could buy server capacity by the hour. They started out at about 10 cents an hour. Now you can get it for 2 cents an hour. They even have a free tier where you can get it for 0 cents an hour. But the really, really cool thing that no one had ever done before was this, that you could rent 1,000 computers for an hour, or you could rent a single one for 1,000 hours, and it was the same amount of money. Never before had there been an opportunity where any one of us, by plunking down a credit card, could say, I need 1,000 computers because I have a 1,000-way parallel job that I could run in about an hour. That was huge. And that's what we now call public cloud computing or utility computing, take your pick. It basically means anybody at all can rent capacity for the amount of time and number of machines they need. There's now 3 or 4 different providers that are competing in this field. And by the way, because those data centers are managed by people whose sole job it is to do that, they will probably do a better job than you if you owned those computers and had to hire your own technical personnel to do that. So another way of saying that is that the total cost of ownership from the point of view of the app developer, that's us, is actually more favorable. Because we're not just getting the computing resources, we're essentially getting the human beings who are managing those resources on our behalf, probably more thoroughly than we could. We can scale up and down instantly. So if you decide that all of a sudden, instead of 1,000, you need 2,000, in the old days, you'd have to order 1,000 computers, and it takes weeks to get them and rack them and set them up. With AWS, you just say, I want more. And as long as your credit card doesn't get declined, you can expand elastically, basically, as far as you want. And that was really important because that's the thing that leveled the field for people like us. As an individual developer, you could now aspire to have an application that was so popular that it could scale from nothing to millions of users in weeks, and there was actually a way that you'd be able to handle, to serve all those millions of users. That had never been a thing before. And probably one of the earliest success stories about that was a game called Farmville. If anybody remembers Zynga's Farmville. They got to 1 million users in their first 4 days. Within 9 months, they had 75 million users. Prior to that, the largest, most successful online game had been around 5 million users, and they did it all on AWS. Imagine if you were Zynga and you went to some investor saying, we have this great idea for a game. We think we're going to get 75 million users in 9 months. We would like enough money to buy thousands of computers. Right? That's a hard argument to make. But if you're only buying computers as you need them, and then when people get disenchanted of your game and they move on to Candy Crush Saga, you can just release those computers and not pay for them anymore, that's a very different value proposition. So today we sort of take it for granted, but in 2007, this was huge. Those of you who don't know this, Netflix basically does not own any of the infrastructure that they use for streaming movies. They are perhaps the single largest customer on AWS. And there's great talks that you can look for online where they talk about why this has turned out to be such a great decision. So even at the scale of something like Netflix, this has really refactored the way that we think about buying computation. Right? So again, today, this is something we seem to kind of take for granted. But as early as, or as recently as 10 years ago.
Okay, a quick comment on that. So actually, Netflix, they do own quite some infrastructure for their streaming service, because I did some research on the CDN infrastructure and figured out actually Netflix open source their CDN hardware, and they actually install, I think, at least like thousands or probably more than that, CDN boxes into backbone ISP server rooms. So this last statement is not necessarily true, but this is a side note. We'll continue.
This is not the way things were done. This has all sort of happened within your pre-college lifetimes. Question?
Me?
Yeah.
Yeah. Isn't it kind of dangerous to be dependent to another company for something so big? Like if something happens to Amazon, like web services, that means that like Zynga, Netflix, most of the other companies would go down too, right?
That is a great question. So the question is, isn't it kind of a big risk to sort of put all your eggs in one basket? Because now all these different companies using AWS, if AWS goes down, all those companies basically go offline. And there have been some very visible outages in the past where AWS has had a failure that significantly affected one or more of their clients. However, one of the ways to mitigate that is AWS has multiple data centers, not only in the US, but outside the US as well. And any company that really needs that level of redundancy can set up operations in multiple data centers and fail over. Now, the engineering to do that is somewhat beyond the scope of this course, but the real lesson is, even if you weren't using AWS, even if you had all of your own equipment, you would still have to worry about that, right? If you have all of your equipment housed in Chicago in a data center, and Chicago gets hit by a snowstorm and the power goes out, you still have the same problem. You would have had to make plans to have redundant infrastructure in other physical locations and have the software mechanism to fail over if something happens to go wrong. So Amazon is now providing the infrastructure to do that and a level of professional management to do it. You still have to do the software engineering to get it right, but I think there's a strong case to be made that the management of the technology is still in better hands with people who are only doing that. And certainly, I feel like my data is probably safer at Amazon than on any machine that I own, which in fact is why that's where it lives. By the way, I don't work for Amazon or anything like that. I get no kickback. But this is one of the reasons that this computer is like 5 years old. I wish I had a bumper sticker or something that says my other computer is AWS. Because really, this is what I use for personal development. But anything else that's reasonable, that people care about, I deploy in the cloud. And that's my backup. Other question? Yes?
So if you're using server computers for computation, it makes sense that we could scale up and down by letting other computers do this task or that task. But in clients like Netflix, where they have to store data, how does that work? Does Amazon store a lot of data to a lot of computers and delete it away when they don't use it, or how does data storage work across a big warehouse?
How does data storage work at warehouse scale? It's not a 1-minute answer, but I'll give you a sketch of the answer. It is not, in a setup like what Netflix would have, it is not necessarily the case that any computer in any data center that is under Netflix's management is always able to serve a copy of any video stream. So for example, some movies are super, super popular. The ability to serve those movies is widely distributed because they expect a lot of different people might want to watch them at the same time. The capacity for serving much less popular stuff, you might be directed to one of a small number of servers that has that copy of Mrs. Miniver or some other classic 1945 film that very few people know about, but they have to have it available for you. So there's a fair amount of allocation that has to go on, and the general answer is not every computer can always do every task. And there is a risk that if Mrs. Miniver suddenly becomes super, super popular, they won't have enough servers available to provision it, and you'll get that message that says, we can't stream this right now, but try again later. And then they can start doing background copies to move more copies of that data closer to where it's needed. So I'm oversimplifying a lot, but that's the idea of how it would be done. Okay? So we love the cloud. We love software as a service. We're going to use it. It all sounds great on paper. Inexpensive warehouse-sized clusters. They cost roughly nothing per hour. The potential for unlimited scalability. But you have to design scalability into the software too. So a lot of times, I've had students who will come to my office hours and say, hey, I'm working on an extracurricular project. It's going to be a software as a service app. It's going to be awesomely popular. We want it to be highly scalable. That term masks a tremendous amount of complexity. So one of the things that we are going to discuss during this course, hey, maybe you will be the next Farmville or Candy Crush or whatever, but thinking about, as an app developer, how to avoid painting yourself into a scalability corner. Because scalability isn't magic. There's a lot of great things about the classic architecture of software as a service that we're going to be using that make it somewhat easier to realize the potential for the scalability that you can get from cloud computing, but it's not free. And it is absolutely possible to do things that will shoot yourself in the foot. And it's not because Rails doesn't scale. It's not because Node.js gives you the power to get close to the metal. It's none of that stuff. It is thinking about architecture and what operations you're asking your app to do that fundamentally have scaling problems. And this question that we had before about, well, what if your app is serving data and not every user wants the same data? How do you know that you've got copies of the right data near the right user? That's an example of a scalability issue, right? So there is no magic bullet in terms of language, technology, stack, or anything like that that will make your app more scalable. But when we come to a juncture where we say, if you're not careful about how you use this functionality, here's the reason why it could become a scaling bottleneck for your app. Those are things that we are going to highlight. And one reason that I think you'll find that very useful is, even though we're going to be deploying our apps on Heroku, which is a pretty standard infrastructure or platform as a service, they provide a lot of managed stacks for you. And I've been asked by some students, well, isn't that really limiting in terms of if you want to scale out a lot further? The reason that we focus on it in this class is because the exact same pitfalls that could come to bite you in the butt on Heroku and thwart scalability there, even if you had a different do-it-yourself, I'm writing all my own code on my own clusters, you would still have to work with those exact same issues. So the kind of thinking we need to get you into is exactly the same for both cases. Things that thwart scalability will bite you whether you're using somebody else's curated stack or whether you're trying to do it yourself.
Right, so last thing I want to bring up for this video is the scalability we're talking about here is actually, horizontal scalability. Because when we talk about scale, it actually can mean very different things, right? One way we could say is this code or this code base scalable. In that sense, scalability means is this code or this code base or this architecture designed to be good enough that would allow more developers to get involved in a project, right? So that's one scalability. And the other thing would be when we talk about cloud computing, there's vertical scalability, meaning a server, let's say a web server that's running the web application, it can scale vertically, which means basically the server can become more powerful. Let's say in AWS, it got different sizes, for instance. But let's say we have, at the moment, an application runs on a server that has like 2 CPU, 4 GB memory. Then if we scale it vertically, it means we basically change it to a more powerful server, right? We can upgrade the server to 4 CPU with 8 GB memory and even bigger than that. So that's yet another scalability it can mean. But here, what we're specifically talking about is horizontal scalability, meaning basically, can this software be run in parallel on multiple servers, right? Then once the software supports something like that, then it can technically scale what we call horizontally, meaning we can then, as long as the software can or the web application can run on 2 servers, then technically there should be no difference if we run it on even more servers. But usually for web application, in order to do something like that, there are a couple of issues need to solve, like how do we handle cookies, user session data, how do we handle cache data, how do we store user-generated contents, so text content usually go to, for example, a database, right? Then that's fine because 2 web server can access the same database, and then we'll see the same data. But for like a user that uploads the image, then usually by default, image gets uploaded to the server that user accesses, but then the other server won't have the image that was uploaded. So these are some typical issues that need to be solved or addressed in order to have a web application scalable in that sense, horizontally scalable in that sense. So I want to clarify that because if we just say scalable, it's actually pretty big. All right, let's move on to the next video actually. 1 second. So we will actually skip 2 videos. If you go to the edX course content, you will find that there are total 10 videos for module 1. We will actually skip video 1.8 and 1.10. For 1.8, it's simply it briefly talks about the web and browser and mobile, these things. I don't think it's good enough because it's really just a like 10 minutes crash course talking about web technology. But if you actually really want to, if you don't know web, probably even with that 10 minutes, you won't understand it at all. And if you already understand web, then it's kind of redundant. So I'll skip that. But if you're interested, you can always go back to edX and then watch that video, which is 1.8. And we will also skip 1.10, but you can always watch that. And if you are not familiar with web or web development, I again encourage you to take the web development course, which is also offered this quarter. Okay, so we'll skip that 1.8, which talked about web, browser, and mobile. And let's get started with legacy code.
So this is the 60-60 rule, and this is well documented over 50 years of software projects. 60% of the cost of maintenance is enhancements, and 60% of the software cost total is maintenance. Right? So of the total budget for a software project, you'll spend almost 2/3 in the maintenance aspects, and of that maintenance aspect, almost 2/3 of that is enhancements to add new functionality or update things, as opposed to actually fixing bugs. In fact, bug fixing is only 17% on average across many projects of the maintenance costs. So legacy code matters a lot. And I would say that in some sense, given how much of the software budget it consumes, it is the most important lifecycle phase of software. Robert Glass, who has done a lot of the studies from which I'm quoting, has this quote that he says, "Old hardware becomes obsolete. Old software goes into production every night," which means we need a way to understand and safely modify old software. How old? Here is a table of some of your tax dollars at work. You cannot read this, but I will enlarge the top line for you. It's the IRS, or Department of the Treasury individual master file. It is the thing the IRS basically uses to figure out your income taxes. It is written in assembly language, a low-level code that is difficult to write and maintain. Tell me about it. Okay? The agency reported age of that software is 56 years. That's legacy. I mean, that's older than me. It's like the only thing we're going to discuss in this class that's older than me. But legacy code means it is still solving somebody's problem. That's why it continues to be deployed. It's still adding value to some customer, even if the technology that it is built from is inelegant or antiquated by today's standards. So this is an important concept that most software engineering courses ignore. In our case, we also care about beautiful code. Beautiful code is code that meets the customer's needs, and it's easier to evolve. And in some sense, I think my challenge is to kind of get these two ideas merged in your collective heads, to remember that legacy code can be beautiful. And the way that we're going to approach that problem or that challenge is you'll see that a lot of the techniques that Agile brings to bear for embracing change, the flip side of those techniques is that they help you manage legacy code. Because legacy code really is just managing change over longer timescales than one iteration. So this is what sort of Dave Patterson and I really tried to synthesize in the book, and I hope that it'll come through as we talk about this content when we get to the legacy code part of the course.
All right, so that's a quick one. That's also the last video we are going to watch for Module 1. Talking about legacy code, although we will dedicate an entire week talking about legacy code, but I want us to always remember one alternative we can always apply to deal with legacy code is just throw it away and start from scratch. And actually that happens a lot in real projects. But I mean, even for big companies like Microsoft, Google, Facebook, they also throw away codes. That's still common today, especially like if you're dealing with legacy code that was not developed with sustainability in mind, or developed not following the principles we're going to teach in this course, then most likely it's not only legacy code but also like spaghetti code, meaning all tangled and difficult to understand, difficult to maintain. So when that's the case, sometimes it actually makes sense just to throw it away. And and then another benefit of restarting a code base would be you have access to new tools, right? Some tools that may not be available 5, 10 years ago when the code was written, now it's available, and hopefully some of those tools can help you to be very productive. And let's say you could just save half of the time when developing um, it from scratch, but still achieve the same functionality. But also sometimes it's not an option if the legacy project or the legacy code is too complicated, which can happen. For example, if something is built by, let's say, a team of 10 developers over the time of like 5 years, then that should have some complexity. And if it's handed over to a single person team uh, to pick it up and add new feature and maintain it, fix bugs, then sometimes it's not feasible for one single person to reproduce the same functionality uh, from scratch. Right. In that case, that may not be an option, but otherwise, and also commonly, usually what I see from most of our ministries, projects don't get that complex. So, because most of the projects are just one man team build it a few months or no more than a year, something like that. Then in that case, as long as you could figure out the specifications, meaning what are the actual functionalities the legacy code implements, it's actually sometimes not a bad idea to just start it over all again. All right, so that being said, that's all for module 1. And then I want to reiterate the homework for the first week, and actually for module 1 is to read the first chapter from the textbook and write a summary and possibly your reflection if you have any, and submit it in Popular. All right, let's take a 5-minute break. At the same time, if you've got any questions, feel free to ask in the chat, and I will take this time to answer your questions while others taking the break. And then we will regroup at actually everybody is in different time zone, so we will just regroup in 5 minutes. If you don't have question, go ahead and take a break. If you have question, take this time to ask it, and then we will start talking about learning a new programming language. Okay. So hopefully everybody is back. I don't see any questions in the chat. Still, if you want to review the course or reading the book, if you got any questions, feel free to let me know. Okay, so now let's move on to the second module. So for this module, we talk about learning a new language. Actually, in that edX course, quite a few videos are really just a Ruby crash course, which is again something that I don't believe in. Like learning a new language, a crash course doesn't work for learning a new language. Same applies to learning like web technology. So I'll skip those. Basically, video 2.3 all the way through the end. But again, still something if you're interested in, feel free to watch it after the lecture. You're more than welcome to do so. But as an alternative, if you have your own preferred way in terms of learning a programming language, feel free to do so as well. In the book website, so you can find the link here in the course syllabus, the textbook PDF downloads, links to the book website. There you could actually find some materials for Ruby. So if you click students up here on that website, you'll find these links that goes to some additional resources, learning resources for Ruby. Like Try Ruby, I think that's a online no, it's not. Okay. So yeah, it's basically some more online courses that's specifically talking about Ruby. And you could also find that on Codami. And then if you want to go further, here's the other resources you can learn more. And we will actually use Code Walls next week, which will be our third lecture. So the third lecture, which is next Tuesday, will be a practice session where I will send a list of links where you can see the programming challenges basically, and then try to solve it. It's all online, so if you learn that way, you don't actually need to install any software on your computer. You don't need to install Ruby, anything else. You don't need that. You could just use the online version to try it out. So that's that. And then I will talk about some more tools and then list out some more resources after we finish watching the videos. Okay, let's get to the video.
Because this course focuses on software as a service, it's common for students to ask questions like, will this course teach me Ruby on Rails? Or will this course teach me JavaScript? Of course, part of the answer is that nobody can teach you how to use a new programming language. You have to learn it, though we hope that we can help. But even considering that, the answer is still not quite, for two reasons. Reason number one, programming languages come and go with remarkable speed. Here's the family tree of programming languages displayed at the Computer History Museum in Mountain View, California. At different times, software as a service has been written in C, Perl, Java, PHP, Ruby, Python, and JavaScript. Considering that software as a service has only been with us since about 1995, That's roughly a new language every 5 years. So knowing a language is a less valuable skill than knowing how to learn a language. That's how we're going to present our exposition of Ruby and later of JavaScript. Reason number 2. Often, the motivation to learn a new programming language is to use a particularly winning framework that requires it. Ruby had been around for 10 years before Rails made it popular, because not only was Rails a great framework for building software as a service, it also took tasteful advantage of Ruby's unique language features, such as introspection and metaprogramming, to make the framework productive and fun to use. Learning a new language and framework together allows you to understand how and why the framework and language work well together, and how specific features of the language support the goals of the framework. Another way to say this is that every programming language has its idioms, that is, language constructs that experienced programmers in that language can deploy to solve particular programming problems with unusual elegance. To paraphrase an old saying, it's easy to learn to write Fortran in any language. Learning to use a language's idioms effectively is one thing that distinguishes great programmers from good ones. A word of advice: find a development environment you like, whether that's an integrated development environment or IDE, or a powerful editor like Emacs or Sublime Text and a collection of command line tools. Learning a development environment is like moving into a new home. At first, you set up just enough to do basic day-to-day chores. But as time goes on, you really want to make it your own because you're going to spend a lot of time there. In particular, learn to activate and use features like automatic indentation and syntax highlighting, which all modern editors have, to help learn and follow the conventions of the language you're working in. So without further ado, get ready to learn how to learn a language and framework, starting with Ruby.
Okay, so that's the intro. For Module 2, I do want to reiterate on the point that Professor already made. So for developer, it's really important to have skill to learn a new language, because most of the time you don't get to choose what kind of project you're running into, and then depending on the project, the requirements, the features you're looking for, you may need different tools, different frameworks, right? A few examples, again, like a traditional or conventional web application, sometimes it's a good idea to just use Ruby on Rails, and I'm a strong believer for Ruby on Rails for conventional web applications. According to my experience, it's pretty fast in terms of building something like that. But take another example. If you're working on a project that deals with data science, AI, that kind of thing, then there's no such thing in Ruby. Of course, you can still build these things in Ruby, but you don't get to use all those matured frameworks, libraries, packages that's open source and already out there and available. Rather, if you're working on something related to data science, machine learning, AI, most likely you will need to use Python, which is a very popular language among the data science community. Of course, there are other tools and the languages available, but definitely not something like Ruby or JS. And then another example, let's say you want to build a CMS, right? I would bet most of you have at least heard of something like WordPress. Then let's say if you want to build a CMS site in a relatively short time, then WordPress might be your option. Then in that case, you again don't have the option to choose like which programming language you use, because of tool, that will determine the language you would use for a project. And then if I go on, there will be many examples. Basically what we're talking about is what's important for a project is the tools and the framework or engine, whatever you name it. Then, so depending on what kind of project it is, what kind of feature we're running for, we need to use different tools. And depending on the tools, we need to use different languages. So that's why it's very important for a good programmer to actually be able to pick up a language pretty fast. Again, when we talk about learning a new language, which we actually mentioned when we talk about learning a tool, is that you don't have to master it right away, right? It will take time and practice and doing real coding, real world project for you to fine-tune your skill and master the language and understand all the ins and outs of the language, and most likely through debugging and then running into some issues before you realize, oh, a language has this feature or something, some pitfalls. But what we're talking about here is you should be able to pick up a language. For example, in a week or two or no more than a month, with a good understanding of like how to do the basic things like assign value, declare a variable, create a class if you know about OOP, other things like how to define a function or a method, how to do loop, how to do conditional condition, these basic things, right? And we actually will talk about a few other features that are usually available, like how to install packages or libraries that's already available. So that's about learning a new language. We will get to the next video.
How to learn new languages in stacks. So why do we care about this topic? This is why I said we're not going to teach you Ruby or Rails or anything else. You're going to learn those things, but not because we're going to present that material. We're going to present a way to think about absorbing a new language or a new framework. And I really have to say a new framework because I think today frameworks drive the adoption of languages. Most people don't want to learn JavaScript. They want to learn how to write cool apps with React. Most people don't want to learn Ruby, but they've heard that Rails is a pretty good framework for writing the server side of those apps. So a lot of the times, the learning of a language and all of the baggage that comes with it really is because you want to use the language with a particular problem. Now, the bad news is if you sort of look at the history of software, even in software as a service, is littered with frameworks. The venerable CGI bin from 1990, through PHP, Java server pages, ASP.NET, and today an unholy proliferation of JavaScript-oriented front-end frameworks. The good news for you is that all of those frameworks are based on imperative, object-oriented languages, languages in which you specify step-by-step what to do, and in which you do data hiding by declaring classes, methods that operate on instances of those classes, and ways to connect them together. From that point of view, all of those languages are far more alike than they are different. And what makes a valuable developer when you're out there trying to get hired is not which stacks you know, it's how fast you can learn a new one and start being productive in it. So we have come up with a 3-stage plan for learning a new language in Stack. The first step is, well, you have to learn the language. But there's a systematic way that you can do this. There's a series of questions you can ask that will allow you to relate concepts in the new language to maybe something you already know from a language you're familiar with. That's why I had to start by assuming that you're comfortable in at least one imperative object-oriented language. It gives you a baseline. Once you've learned the language, and I'll tell you our 8-step plan for learning the language, the next thing is to understand what is the application architecture your framework supports. To say that you are learning React is to say that you are learning an essentially data flow-based view of the world in which data percolates from the root of the tree down to the branches and changes are automatically handled for you. To say that you are learning Rails as a server framework means you are understanding that apps can be thought of as structured model view controller, that those are entities that have a particular role and they influence how you organize the app, and the framework is there to support that kind of architecture. So understanding what the framework wants you to do, right? Because what you'll find is if the type of app you're writing is structurally poorly matched to your framework, you're going to be in a world of pain, because most frameworks make it really easy to follow the structure they have and really painful if you don't. And finally, having understood the language and the architecture, all you have left to do is to understand the mapping between the two. And what that means is, what are the things in the language that allow the framework to provide the abstractions that it provides? Right? So if you can do these three things, if you break down your task of learning a new language and framework into these three steps, we believe that you'll develop a general scheme for becoming rapidly productive. So what does that look like? We have an 8-step plan for learning the language. And this is where I'm going to invite you to go read the draft chapter of the brand new, not even yet published 2nd edition book. It's linked from the syllabus. But the 8-step plan is as follows. First of all, how does the language deal with types and typing? Do types matter? How do you specify them? What are the primitive things you can do? How do you do basic stuff like conditionals, loops, transfer of control, things like that? How do you define functions? Functions are a basic building block in any imperative object-oriented language. So how do you deal with things like parameters, things like return values? How does scope work inside of a function? Abstraction and encapsulation. How can you hide data? How can you group together items of data and operations you can do on those data? And in most languages that we would look at in a course like this, it will have to do with how those languages let you talk about objects and maybe about classes, and do they support things like inheritance? So what are the methods of hiding data from the view of entities that don't need it, and how do those things get done in the language that you're trying to learn? What are the idioms of the language? We'll come back to this because this is really important, but this is the one thing about learning a new language that is usually the biggest stumbling block. There are ways of doing things in that language that don't look exactly like a way of doing it in a language that you already know. And sometimes learning those idioms can be really hard. I mean, for me, it's like when I first had to learn pointers. It took me like a month to understand pointers because I had never dealt with a language that pointers were a thing. So there's a certain amount of banging your head against the wall to get this, but it's really important, in part because really good frameworks will take advantage of the language idioms to make the framework easier to use. The framework assumes you know how to use the idioms well, and it will give you a way to leverage that to your advantage. Libraries. Most languages are easier to learn than the libraries that support them. So how do you do libraries? How do you manage dependencies when your app depends on a lot of different libraries? Are there tools available to help you do that, like pip for Python, or like bundler for Ruby, or like npm if you're programming in JavaScript, heaven help you? How do you do debugging? Does the language have an interactive debugger where you can get in and poke around? Can you print the values of things? Can you have the debugger trigger when a variable changes its value or when some other condition happens? And how do you test stuff? What testing framework allows you to sort of cross-check what you're doing by always being able to write little tests that act as sanity checks against your code? That is our 8-step plan for learning the language, and it is not without a few pitfalls. In particular, there's a quote, and I don't know who it's attributed to, that says, you can write Fortran in any language. Here's what that quote means. What is this? It's a hot dog. Do we have any German speakers in the room? Any German speakers at all? No. OK, well, I'll still make this work. If you were a German speaker and you translated each of those two words, heiße is hot, Hund is dog. And yet, heiße Hund doesn't mean hot dog. It actually means a dog in heat. So if you go to a street vendor and ask for that, you will get the wrong thing because you have not learned the idioms of the language. Hot dog is an idiom in English. So there are going to be weird idioms in Ruby and JavaScript and other languages, and understanding how those idioms change a little bit the way that you approach the language is one of the key ways that you become a person who thinks in Ruby or thinks in JavaScript. Lastly, as a debugging tip about blindly copy-pasting, the MIT AI Lab, one of the very earliest hotbeds of really interesting computing hardware and software, developed this sort of legend about the koans, Zen puzzles. One of the koans goes that Marvin Minsky, one of the sort of fathers of symbolic AI, came into the AI lab one day, and there was a novice, probably a PhD student, who was repeatedly rebooting a machine. And Marvin Minsky said, why do you repeatedly reboot the machine? And the student said, it's not working properly, and I thought by rebooting it, I could get it to do the right thing. And Minsky says, You cannot simply reboot a machine with no understanding of what's going wrong and then expect that to fix the problem. Minsky then rebooted the machine, and the machine worked. I leave you to derive from that what you will. But don't copy-paste code if you don't know where it's been. Okay? Last slide. Advice. We're going to help you learn from the internet. The internet is awesome. I could never have learned Ruby or any other language without Stack Overflow. But Google it first, all right? Find the nouns and verbs of the sentence. If you're asking your buddy, hey, how do you get the keys out of a hash in Ruby? Well, if you type in just the nouns and verbs, you'll probably get pointers to the top 3 or 4 Stack Overflow questions. It is not unusual to spend way more time looking up stuff and finding good examples of how to do it as the amount of time you spend actually writing code. Don't be surprised if you say, oh my gosh, I've been programming for like an hour and I wrote like 6 lines. If those 6 lines are well informed, because you spent the rest of that hour actually researching what are the different ways to do this so you could find a good way, that time will be repaid over and over. Does the answer have a lot of upvotes? Is it from a reputable site like Stack Overflow? Probably a better answer. You could even read the real documentation. Once you've seen a few examples, take a look at what's possible in detail, read the actual library docs. And finally, don't copy-paste code you don't understand. To see if you understand it, try to insert a bug in it. After it works and you think it's doing what you like, change something about it and see if you understand the effect. We'll have much more tips about this, but start learning Ruby because we're going to do some Ruby fun things on Thursday. Thank you for your attention. See you in a couple of days.
Alright, that's the second video for Module 2. I do want to say Google is going to be your friend if you haven't do that yet. Even for me today, I think every day I need to Google something. And I would say even if you master the language, probably you still need to get back to Google. Like even for somebody like me, I think also it's part of all the things I work on, because I have to like hop between different programming languages. Today I may be working on a project that's written in Ruby. The other day maybe dealing with JavaScript. Then the third day, maybe PHP, and then sometimes work on Python a bit. All that. I honestly keep forgetting the syntax for every single language, and also sometimes it gets really confusing once you learn all these programming languages. So funny enough, I almost every day I need to Google something, even for something very basic. But the point is, what's important after Googling this stuff, you need to understand the idea behind the code, right? You need to understand what that code is exactly doing. Otherwise, you'll just end up with copy and pasting what the professor mentioned, and that's something you should be avoid. But otherwise, like for example, if you just cannot memorize the syntax for a language, or the other thing, like if you take the data structure and algorithm course, like if you cannot memorize a sort algorithm, that's actually totally fine, as long as you understand the principle, the idea behind the algorithm, or the idea behind some code, or some syntax. Then it's perfectly fine for you to just Google it and then find it and just copy and paste it, right? But don't just do that blindly without looking into the code and understand what it is trying to do. Okay, so let's get to the last video we will watch today, and I will talk a little bit more about learning a new language.
I actually want to start off talking about pair programming, because it's something that in today's or tomorrow's section, whichever you attend, we're going to have you try. We're hoping that some of you decide that it's actually worth continuing through the semester, but we're not going to mandate that you do it. We think your life will actually be a lot more fun and a lot easier if you do. And I know that the sort of the stereotype, at least when I was in grad school, is you sort of go into a room by yourself, you hack for a long time, you drink a lot of Red Bull, although there was no Red Bull back then. And at one point, it made sense to ask, what happens if multiple smart people who are part of a team actually find a way to do programming together. And if you remember, last time when I briefly talked about Agile and extreme programming, one of the motivations for pair programming is if code reviews are a good thing, then have two people programming so you're sort of always reviewing each other's code. So the idea is to improve the quality of the software and ideally take less time to complete it. And there's a lot of companies that actually swear by it. Some companies essentially mandate that all of their devs do it. So what is pair programming besides programming in pairs? It is actually a thing. There's a protocol for doing it. We took these photos at Pivotal Labs. We are big fans of what they do and vice versa. In a typical pair programming scenario, you'll have the two developers sitting side by side. One of them is at the keyboard. That's the driver. And the other one is the observer. And these are actually workstations that are set up only with the stuff that they need to be doing to write their code. So there's no email reader open. You can see the only browsers that are open are viewing things like documentation or the project tracker. So the idea here is that at any given time, the driver is the person typing code and sort of thinking out loud as she types. So OK, we need to be able to call this function, and I think these are the right arguments. The observer is sanity checking, cross-checking everything they do. Also, the observer has kind of an eye on what the next step is and is sort of thinking a couple of steps ahead. So both people are actively thinking at the whole during the entire time. It doesn't mean that one person's driving and the other person's like checking their phone or something like that. Both persons are engaged all the time, and people who do this and spend most of their day coding in this pair programming setup will tell you that it is mentally exhausting because everybody is on all the time. Every 10 minutes, maybe, you switch roles. So if you're the observer, now you become the driver. Driver becomes the observer. And in fact, we can take some extensions of that. So do change roles frequently. You're going to try this in section today and tomorrow. Whichever role you're doing, you're exercising different skills. If you're not the person typing, you're the person who's sort of cross-checking and sort of looking critically at the code. If you are the person typing, you're also supposed to be kind of thinking out loud, describing to the observer what it is your thought process and why you're typing what you're typing. And as I'm sure many of you know, especially if you've had the chance to be a UGSI or a lab assistant, explaining things is one way to get better at learning those things. So even if you're pairing with someone who have a very different experience level from you, you will both get something out of it every time you switch roles. Don't judge your peers. Some people are stronger in some areas than others. This is a chance to teach them, and it's also a way to teach yourself. So we're going to recognize your efforts in this class. We'll survey your peers and ask, if someone was a really great pairing partner, that's the kind of thing that we actually think is valuable in terms of even your course grade. And it is certainly valued in industry. The ability to work in a pair like that where you're not only contributing to the project, but you're helping your peers become better in the project. And needless to say, whichever role you're doing, you should be 100% focused on that role. So if you do this for like an hour and you feel like you've been coding for 3 hours because it's so sort of mentally draining to be that focused, then you're probably doing it right. And yeah, the first time you ever do this, you might feel a little bit awkward. You'll get used to it really fast. In fact, we'll talk about promiscuous pairing, which is a way to sort of swap partners as often as possible. And you get better at having those skills so you don't sort of fall into a routine with the same partner every time. Empirically, when the task complexity is low, so the code you're writing is not that hard, pair programming is usually quicker, and you get higher quality code because you've always kind of got two sets of eyes. Higher quality doesn't just mean that it's less likely to have silly bugs. It also means that it is more readable because you've got another person right there who's kind of cross-checking you saying, wait a minute, why did you write it that way when it might have been less confusing maybe if you expressed it this other way? Now, it's more effort than solo programming because technically you've got two people doing the job that one person would otherwise have done. But notwithstanding, this has sort of proven its weight in industry as a way that, on the whole, it leads to better quality code, usually produced quicker, and spreads knowledge between the pair and throughout the team. Not just knowledge of programming, but for example, if one of the pair knows like a trick for using a certain keystroke in the editor or things like that, right? So all the kinds of things that when you casually work together with your student peers, you find that you sort of pick up stuff from them. This is a way to sort of formalize that. I mentioned that some companies are so serious about this that they promote something called promiscuous pairing, which is you basically partner with everybody. So for example, if you're in a team of 6, there's 6 choose 2 ways that you can pair up. And if the team is sort of all programmed together, you'll actually swap not only roles with your partner, but you'll also swap partners. And that's a way of disseminating information throughout the whole team. Should you try pair programming for CS 169? Don't ask me. Ask the students who took CS 169 last year, which was the last time that I taught it. Periodically, you're going to see a slide like this that has a top 10 medal. At the end of every semester, we ask the CS 169 students, tell us about the top things that either you would recommend to your classmates that they should do, or that you would do differently, knowing what you know now and if you were taking the class again. Number 6 on the list was do pair programming. It helps avoid silly mistakes, so it tends to save some time. And yes, changing partners frequently made the team more cohesive because everybody on the team sort of had a sense of how the other people on the team were thinking and what made their gears click. Okay, so you're going to try this hopefully today or tomorrow, whichever section you go to. We hope that you will like it enough that you'll adopt it, and we are cool with having you pair program basically on all the homeworks. As long as everybody turns in their own work and it's clear who you were pairing with, or if you were pairing with multiple people, sort of who your study group was, we're in favor, okay?
Alright, so that was last video talking about pair programming. So in this course, we are actually not going to do pair programming, but if you can find the partner, feel free to do so. It's not required, and I think it's kind of not feasible given that everybody is in different location. There are ways to do remote pair programming, but I'm not really sure about that. I did spend some time looking at different services that says they could do remote pair programming, but I don't think that works that well. And then, do you want to share some personal experience with pair programming? I'm honestly not a strong believer in terms of pair programming. Especially when we talk about productivity. Basically, we are spending two people, for one task. Of course, there are benefits in that, but is the benefits worth doubling? Right, basically, we're doubling the man month. If you read the mythical man months, we're basically doubling the man month or the workload because we're pairing two people into a task. So I'm not quite convinced in that. Although, like if a procedure do require something like code review, then that's a different story, because in that case, when two people, two developers are paired, one is actually doing the code review, whereas otherwise the code review will be done separately, and the task to review the code will also take time, right? And the joke is many times usually the supervisor or the team lead or the more senior developer will do the code review, and sometimes they don't. They just browse through it and click approve. That always happens. So that's one thing. And then a few other experiences. So I did try pair programming in different projects with different people. The other thing I observe is like pair programming is not that effective when the skill gap is too big. Once or twice, I was trying pairing with somebody quite new to programming, and in that scenario, when I'm the driver and the other person or the beginner is the observer, it's just really difficult for him or her to understand what I'm trying to do. Basically means when the skill gap is too big, it's difficult to actually transfer the knowledge. Or like everything the senior one that's writing the code, the junior one, just it's really difficult for him or her to understand what's going on. But otherwise, I think pair programming is good. It's worth a try, and it do help, build the team and help the team to be more coherent, as the professor said. It's just, is that really productive? I'm not quite sure about that, but it's for you to decide. Don't take my word for granted. Um, Once you try it, and then I would suggest that try it with different partners, because again, the way people communicate and then the skill level, it's all different. So without trying it multiple times, don't make a conclusion. And even for me, I don't have a conclusion for pair programming yet. And actually, yeah, it's good for transferring knowledge, because otherwise, how would you pass on some good habits, coding habits? How, when you write a specific piece of code, and most likely others won't bother reading it until they need to work on that. So yeah, that's about pair programming. And then we will skip all these other videos from 2.3 all the way to 2.6. But still, during the weekend or when you have time to spare, feel free to watch these videos if you feel like. Otherwise, let's see. So next week we will have one lecture that's dedicated for practicing writing Ruby code. So for this week, of course, you need to work on the homework, the week 1 homework, which is writing a summary. And then hopefully you get time to spare, and I strongly suggest that everybody spare some time on that, and then find whatever tutorial you feel comfortable with. If you are a video guy, feel free to find YouTube videos, YouTube Ruby tutorial videos. For me, I'm not too much into videos, so I usually just find the websites, or sometimes even just go through the documents. And every programming language has its official website, and then they usually pair. They have documents over there, but that's up to you, and it's really personal preference. So you can choose whatever way you prefer to learn a language. Also, next week we will get into some in-depth Ruby stuff. But still, by that, if you get chance, I would encourage you to get started with some basics of Ruby, find a tutorial, learn the basics, the stuff I've mentioned, like how to define a variable, how to assign a value, or primitive data types, how to do if else, for loops, that kind of thing. And although there is actually no for loops in Ruby, but just the way to do loops, how to define functions, methods, how to define an object, class, stuff like that. These are basic, so I would encourage you to, and these shouldn't take too long to learn, honestly. So hopefully you got time, and if so, try to learn those by next Tuesday, where we will actually get some more practice. And then if you have any question while learning the language, feel free to ask me. Actually, there are more things I should talk about. But anyway, that's for like homework, and the other things like learn Ruby is not really required. I won't ask you to submit anything for the week for learning Ruby, so feel free to, if you're busy, it's also okay just to skip it. And then you can find this website, and there are recommended materials here. A few other things I do want to talk about um, regarding learning a new language. One thing is called linter. Linter or linked is basically a static code analysis tool. That's a tool that goes through or scans your code and then find potential bugs, errors, and then style issues. It's really helpful when you learn a new language, because sometimes it will give you good warnings. Like, actually, next week I will show you some examples of a linter. But anyway, it will warn you about style issues, and then I actually learned a lot through these linters when I learn something like Ruby, JavaScript. It really, and then the other one like Dart. It basically gives you advice on how you should do certain piece of code. And most of these advices are actually very sensible and actually really help the code to be more beautiful. And then by writing beautiful code again, we're talking about writing code that's easier to understand and read later, or easier to read for others. So that's about linter example. So since we're going with Ruby, for Ruby there's a gem called roll. Okay, 1 second, I forgot the name. Oh, Robocop, yeah. So Robocop, that's one of the, probably not just one of, just the top linter for Ruby code, Ruby language. It does all the style check. It follows this Ruby style guide. Of course, when we talk about code styles, different people will have different preference. So once you get familiar, comfortable with the language, and then sometimes you can ignore the warnings from these linters. But otherwise, especially at the beginning, I would advise you to like check all the warnings and understand what's it about and how it could actually help you to improve your code styles. Okay, so that's for Ruby. That's Robocop. You could just Google it and probably you can find the GitHub page, and then you can follow the documentation in terms of how to install it and run it. Next thing is Code Walls. Sorry, we will be late for a few minutes. So Code Walls, it's a website. It's actually the website we're going to use next week. It's basically, okay, I cannot get to the home page. Anyway, so this is the dashboard page. If you go there, it will have the home page where it asks you to pick a language, and then it'll give you all those code challenges, and you can start from the easy one and try to practice your skill. So this is also helpful for learning a new programming language, because when you learn, you want to practice, and in order to practice, you actually need to come up with some problem to solve, right? And sometimes it's difficult to come up with these problems, and also like sometimes if you come up with some project for fun, it may not cover some of the features that a language offers. Whereas like a website like this, it offers a good set of questions and challenges for you to solve, and actually it provides solutions if you want to pick into the solution. And last thing, so some of you are new, I believe, to programming, but once you get more experience, and I think once you learn like 2 or 3 or more programming languages, and getting comfortable with that, I would strongly suggest to take compiler course, which you can actually find Stanford offered a free course again on edX. This course is really good if you are interested to learn more about programming language. It really helps you to get more insight and kind of give you a different perspective of looking at a programming language. But yeah, it's something I would suggest for you guys to learn once you learn some more programming languages, and once you are comfortable with that, this one is really helpful for you to go one more step. All right, so that will conclude our lecture today. Feel free to reach out to me if you got any question in terms of this module. But otherwise, we will just end today's lecture. Okay, and then don't forget to finish your week 1 homework. All right, we will end. Bye.